Shall we begin? Hello. Shall we begin?
Yes, sir.
Everybody can see my screen, right? Hello. Hello.
Yes, sir.
Everybody can see my screen, right?
Yes, sir.
Yes, sir.
Yes, we can see the screen.
Okay. All right. So last time when we worked on declaration of variables. Uh, just just a quick recap. You might have all tried doing that. I believe it's so. Just a second. All right. So quick recap what we did last time. So declaration of variable, these are the primitive. So int, float, string, bool, etc. Okay, so these were our primitives, and we had also worked for the monobehavior methods like void start, then void update, then void awake, then on enable, on start, on enable, on awake, on late update. We have fixed update as well, and we have on disable, on destroy. Okay. So these are the basics of mono behavior life cycles, and as I have explained you before, the flow of awake, enable, start, update, late update, the flows as well. So here's the quick recap with that awake will be called on the very first when the script gets enabled or gets created, then on enable, then on start. Then later on we have update method. Update method which calls on every frame. Then we have a late update. So what's the difference between update and late update is the late update executes one frame after the update method, so that's why it is called late update. So it calls after the frame updates. Okay, so camera sync and all those kind of things are being preferred on late update. And fixed update works with the default timestamp, default time scale. Okay, most commonly used for physics updates. Okay, and which I mentioned last time, when the game objects gets inactive or disabled, this method gets invoked. Also, the key difference between enable and start is enable invokes before start, and start method only gets invoked once the game object gets active. On enable gets invoked every time while while the game objects gets enabled. So each time the game object gets enabled, this method will get called. Similarly, for the disable method, it will only call when the game object gets disabled. Clear till now? Hello? Clear till now?
Yes, sir.
Okay. So a transform do have coordinates with x, y, and z axis. You might be aware with that. So let's say if I create a new game object, basically one empty game object, and inside it I kept a cube. Okay, you can see it's the child of the game object. Okay, with its local transform, which is 0 0 0, and also the game object is also 0 0 0. To In order to have a transform controls in your scene, you can shift from here. Okay, so this is a panning tool which you can pan around here and there. This is a transform tool. Okay, or you can say a move tool, which you can move any object, selected game object. Okay, and this is a rotation tool. You can rotate this tool, like you can use rotation techniques. You want to have a rotation in this game objects. And this is scale. You can scale it with respect to any axis, like this, or with this axis, or the entire equivalent scaling. You can directly click from here and can scale it. Okay, and you can see those values are getting updated. Okay, but another thing, in Unity side, if you can see, the child is still 1. Okay, because it is inheriting with the parent values. Okay, it is inheriting it from the parent. So this is the parent, the game object is parent, as I explained on the first lecture, that uh, whichever things are inside the particular game object, or maybe child of the game object, you can simply add it, and for the scale you can multiply it. Okay, so whichever value it is, this scale, however it is, like it is 2, the cube will also increase, but its scale is going to remain the same. Why? Because it is local scaled. Everything, the values if you see in the child are local values. Okay, so it is getting inheriting from the parent values. Okay, so it is like really important that you guys don't confuse like why the scale is different, or why the scale values are different. For that, the key understanding part is the child will always follow the values of the parent. Okay, initially if you want to have a different values of the child, you can simply you can just change the values of the child respectively as you want. This is how it will work, and still it will format in that same way, but it will be little lower than that, which means bit smaller than that. Okay, similarly with the position as well. So this is how it is. And the last time which we worked on the transforms of movement of the particular game object. So let's do with that. So basically, what I'll do is, for the movement of the script, I explained it at the very last, and that too in uh, really quick, to give you an understanding for that. But today I'll give you on a very brief how it is done. Okay, so basically camera is watching over here. You can see the cube here lying around. This is my output window, as I mentioned in the game scene, the game window. Okay, I can keep it as a free aspect. Okay, so whatever camera sees, I'm mentioning it again, whatever the camera sees is being displayed in the game window. Okay, in the game window. So for the movement of this particular game object, we need to have a component which will leverage us to move this particular game object. Okay, so as I mentioned, each and every script, each and every things which you see are itself a script, which Unity denote as components. Okay, so this our script is also a component. Okay, so basically deep down on the technical side, this everything is a component which gets attached to the game object. So whichever things has a mono behavior inheriting from the particular class, like let's say this class is a component. Okay, so it will get attached to the any game object which is available, which is in the scene. Okay, or those they are in prefab. I'll explain what are prefabs in the later lectures, but now I'll explain you how to leverage transform into the movement of the cube, basic movements of the cube. Okay, and how to manipulate the transform values from the script. Okay, any doubts?
No, sir.
No, sir.
Okay, so let me create another script for the movement of this particular game object. Okay, so what I can do is, either I can create a new script or use an existing script. Okay, for now what I'll do is I'll create a new script. Okay, by clicking over here, M capital movement. Okay, I am writing M as a capital because this will be created as a new script. If the script is available, you will be able to see the script over here, but currently we don't have any script for the movement. Okay, so basically why do I write M capital? Because it will be creating a new script. In that new script, it will create a new class. So class always so the first letter of the class should always be capitalized. It is a good practice. It will still work if you have a lower case, but it will be a good practice that for this class, okay, it should have a capital case for first letter. Okay, so for that, here it is asking me to create a new script. So I'll create a new script. It is also telling that create new script. I'll click create and add. Okay, so new script has been created over here. So by default, each and every new scripts by default gets created under the assets folder. And in the previous lectures I have also mentioned how you can find the asset folder or any individual file. In my case, I can just click on reveal in finder. For Windows, it will tell that it will indicate show in Explorer for Windows. For Mac users, it will show reveal in finder. So it will directly point you to that particular location of that particular file. By default, each and every script gets created into the root folder of the asset folder. Okay, so we have created the script and it is also attached over here. Okay, but what if this script has been removed and I want to reattach it? So what I'll do is, so by default it will look like this. So what I'll do is I'll simply type movement. Now previously it was asking me to create a new script, and now it is already suggesting me a new in the existing script. Okay, the existing script. So what I'll do is I'll click on that existing script which I already created before, and it will get attached by clicking on it. To open that script, again I'll double click. Okay, so it will open a new open that script in the respective editor whichever you have. Either it is Visual Studio Code Writer or Visual Studio 2022 Community Edition. As you can see on the new script, it always creates a template for this particular code with our defined name inheriting from mono behavior. Alright, so particularly and we will be using mostly towards the update. Okay, so now how do I leverage particular transform? Like I want to use this particular transform I want to use it. Okay, for the movement of the cube. For the movement of the cube, what parameters I need to change? I'll need to change the positions and which positions, either it can be X, Y or Z. It's a compulsion that you need to define which direction you want to move. Alright, so for this to move particular game object from point A to point B, or maybe you can say infinitely moving towards the direction, we will be using update, because update calls on every frame. So why we write in every frame for this? Because on every frame it will move to X number of units. So every frame, like let's say in each iteration of the call, it, let's say we define it 5 units per frame. Okay, so in each frame the cube will travel 5 units, or maybe towards the X axis, Y axis or Z axis, whichever we define. Okay, so it will travel to particular units on each frame. So let's suppose we have 5 units per frame. Okay, and supposedly our game is running on 30 fps. Okay, so on each frame, okay, so on each second it will travel by 150 units. Okay, so multiplying with directly frames. Okay, so 30 fps into 5, 3 5s are 15, means 150 fps, 150 units. Okay, so let's try. So basically for that well defined structure, for the speed of movement we will create a variable. Okay, variable of float speed. Okay, so this speed will help us to control the speed of that cube. Okay, so this speed will help us to control the speed of the cube. So now this game object, this particular game object has a transform which is compulsory in every game object. So transform is by default attached, and it cannot be removed. This can be removed, but transform cannot be removed. It is fixed. So it does come under this particular game object. So if I write transform, okay, so basically the script, or maybe you can say this script, this means this particular this. Okay, this has a transform. Okay, transform. So I'll write transform dot translate. Okay, so basically transform has a method called translate. Whichever things has this particular thing is called a method. Okay, so update is also a method, translate is also a method. So whichever comes with the bracket, opening and closing rounded brackets, is essentially a method. And you can see a defined color of this method as pale yellowish color. Similarly this is also pale yellowish color. Okay, so that's how you be able to recognize this is a method. Okay, so translate is also a method which is asking for a particular vector. A vector is what? A vector is a class, or maybe you can say a structure of 3 floats: x, y and z. Okay, x, y and z. Okay, so a vector is something with the a vector 3 has 3 vectors. So basically it is x, y and z, and all 3 are floats inside it. Okay, so what I'll write down is new vector 3. Okay, and now I want to move to a particular direction. I want to move it towards x axis, y axis or z axis, whichever I want. So in order to write that, these are the 3 parameters of a vector. Okay, so let me explain what are the parameters actually. So let me create a new method. It can be any method, you can rename it as you want. Okay, so method do also have access modifiers as well. Okay, so it will be void. So in order to write a method, you need to have a method can also return a value and can also return nothing. So each and every method should return anything. Okay, So method should return anything or it can return nothing. So if the method is going to return nothing, so simply we will write void. Okay, void means it won't return anything, it won't return anything. Okay, so note this down. For this particular thing, a method can return anything and it can return nothing. For anything in that particular case, it can be a data type, which can be integer, float, string, or even class as well. Okay, even class as well. So it can be anything. Okay, so for now we will write a method which will have a parameters. Okay, which will have a parameters. So let's say I'll write a method which can be named as abcd for now. So method will have this parenthesis, open and closing bracket, and another curly brackets, as you can see. So it will have, so this method doesn't have any parameters, it is empty parameter method, so it doesn't have anything. Okay, so what are the parameters? We pass something to the method, we pass something to the method, it will catch that particular values, and you can do anything with it. Okay, so these are the, you know, like let's say there is a hole, like let's say square shaped hole. In this square shaped hole you can only fit a cube inside it. In a circular hole you can fit a cylinder or maybe a ball inside it. Okay, so this is what actually it is for the methods in a very layman terms. So let's say, so let's try with one parameter, integer a. Okay, so what will it says that integer a can be passed in abcd method name. Okay, so what I will do is debug dot log a, and how do we call this method? Either we can call it over here. Calling this method is simply writing abcd. Okay, and it is asking, it is giving some error because it is asking for a parameter which is compulsory as defined over here. Okay, for not compulsion values we can define a default value over here, so the error won't be there. Okay, as you can see, it is now letting us to have an empty parameter method. But now let's say we want to have a compulsion for this method to compulsorily pass a method, a value inside the parameter. So let's say to pass a particular value inside abcd, which is first parameter, which is integer a, we can simply pass direct value because it is an integer. Okay, so what will happen is debug dot log will be printed with the value of 10. So this is how method is. Okay, so method can have n number of parameters. Okay, so this is how it can be done. So for example, if I want to add something, add two numbers, so let's say int a, int b. Okay, int a, int b with comma in between. Make sure to separate your parameters with the comma. Okay, so what we can do is int c is equal to a plus b. Okay, so now we can print debug dot log c. So what will be will be passing over here, add method with 5 and 10. So it will print 10 on every frame, it will print 10 because I am calling it on update method. Simply I'll write it on the start method to simplify those things. Okay. Similarly for vector 3, this is in uh, a vector 3 format, which is an invocation and asking for three floats, three particular floats, x, y, and z. Okay, so for this, what I'll do is I'll pass, I want to move my cube from x axis on only on x axis. Okay, only towards the x axis. So what I'll pass is, first parameter is x, second parameter is y, and third parameter is z. Okay, so this is what it is, as you can see. So transform dot translate, the translate method only takes vector 3. Okay, only takes vector 3. Okay, so for that, uh, in vector 3 we are also passing three floats. Okay, three floats. Currently you can see those seems integer to you. You can simply write 0.0 f. For floating values you need to mention f as a suffix to on the number, because it is mandated to have a denotation of a float. Okay, so let's try. The cube is moving really fast, and my fps is around 230 fps, so it is moving really fast. So let me slow it down. Okay, to slow it down we need to have a delta time in between. Okay, so what delta time does is it makes it universally similar pacing of the uh, you know so what it exactly does is it calculates the time in between two frames. Okay, the the time between two frames is something, some values, it has some values. the the higher the frame rate, the lower the value of that particular thing. So let's say, uh, let me give you an example. um, so let me give you an example with this. So let's say your game is running on 30 fps. Okay, the game is running on 30 fps. So on on every 1 second, okay, on every 1 second only 30 frames is getting passed. So the time between one frame is higher. Okay, means it is more than the time taken on 60 fps. Okay, because uh, 60 fps is double than 30 fps. Okay, so in 1 second the time delta difference between two frames is really low. So it will give you a particular value of that frame. Okay, so the higher the frame, the lower the value of the delta time. Okay, so what delta time will do, it will streamline universally uh, formatable value which will be similar on all frames. Okay, so it will be similar to all frames. So whether it will be 200 frames per second or maybe it will be 12 frame per second, the cube will travel in that same distance on every machine. Okay, so this is why we use time dot delta time. Okay, so we'll multiply it with the vector 3. So what will it do is this will be multiplied with this. Okay, and this will be multiplied with this. Okay, and similarly this will be multiplied with this. So it will be multiplied with x, y and z. Okay, so for 5 it will multiply it with some value. Okay, and anything multiplied by 0 is 0. Okay, so now we can see now cube will move in a very streamlined way because it is moving in a fixed units, however the frame rates are. Okay, now I want to have a variable speed of the cube. So what I'll do is I'll simply pass the speed parameter on the first parameter of the cube. Okay, and by default it has been private, so I'll make it public. Okay, so by default value is 0 and cube is not moving. Why? Because 0 is getting passed on the x parameter, similarly for y and z into time dot delta time. Okay, so if I gradually increase the speed, you can see slowly the cube is getting moved from point A to point B. Okay, if I increase it even more, so it will get more fast. If I do it on the 100, so it will pass 100 unit on every second. It will pass 100 units on every second. Okay, and what if I do a negative 100? You can see it will move towards the left. It is moving towards the left because it is negative 100, negative 200, negative 300, so it is more faster. Okay, so this is how you control the value of the speed, how you can control the speed of the cube. And similarly, if you want to have control towards y, I can set the same speed and I can say set 0 on the x-axis. So now if I okay, I have resetted it. Now if I increase the speed, so it will start moving towards y-axis. Okay, no x axis or z axis is getting changed, only y axis is getting changed. So it is traveling 5 units per second. Okay, any doubts? Hello, any doubts?
सर अगर रोटेट या स्केल कराना हो तो
Yes, we can do that as well. In order to have a rotation of the cube, okay, there is another method. Okay, this dot transform dot rotate. In order to have a rotation on that particular axis, it takes a particular axis in the vector 3 or in the quaternion or in the Euler's. Okay, so for the simplification, because rotation is really complicated and it needs quite a mathematics for this, but to simplify our own rotations, we can use transform dot rotate in the Euler forms. So Euler is definitely the direct degrees of the rotations on the axis, because rotation has sometimes in the 3 axis format, rotation can have a gimbal lock. Okay, so basically two axes getting locked. So in order to control those things, we need to have another parameter for that. Okay, so that's an really advanced mathematics for this, but for now, yeah, we can use a rotation for this particular format. Okay, so if you want to rotate on the x axis, again similarly we will be passing vector 3 inside it. Okay, because it is very simplified. Okay, similarly new vector 3 with the parameter of x, which will be our speed. Okay, y0 also z0, and same time dot delta time. Okay, time dot delta time. So what I'll do is, I just don't want to move the cube right now. Okay, so I'll just comment it. And if I go to the cube, if I play, it is not moving because our speed is 0. And if I do 50, so it will start rotating. You can see it is rotating on the x-axis. Okay, if you get confused what axis it is moving, just simply follow the right hand thumb rule, one index finger pointing towards forward. The thumb would be the thumb finger which will be pointing towards upside. Okay, the thumb will be pointing on the x-axis, the middle finger which will be pointing towards x-axis, and the index finger will be pointing to the z-axis. Okay, so if you want to rotate it, just simply hold any of the finger and rotate it. You will be able to figure out how the rotation works. Just like a rod, consider your fingers as a rod and try rotating it. Okay, so you will be able to recognize how rotation works. In this case, you can see on the red part. Okay, this is x-axis, so we are rotating towards the x-axis. Okay, so simply just which we are whoever who rides the bike or the scooty, you might be accelerating in it, correct? So the rotation of that acceleration, okay, the accelerator bar which you are accelerating on your vehicle, is on the x-axis. You are rotating that accelerator in the x-axis. Okay, so this is how it is, the rotation. And similarly, if you want to have a rotation on the different axis, you can just simply change it if you want. Again the speed is 0, so I'll increase it. Now we have done in the y-axis. Okay, so this is the y-axis. So how the cube will rotate? It will rotate like this. It will rotate like this. Okay, if I do a minus 50, it will rotate in the opposite direction, counterclockwise. And for this z, now z is pointing here towards us. It is pointing towards us. Okay, so it will rotate like this. Okay, so in the every 2D game which you will be seeing or working in the future references, most of the parts, the rotation parts which you will be taken care of will be only towards the z axis, because on the 2D axis we only focus on the z axis of the game, or the whichever objects it would be for the 2D games. Okay, so we use only z axis for 2D games. So let's say Flappy Bird. Okay, the Flappy Bird games, when we tap on the screen, the bird flips. Okay, so it is uh, you know uh, you know the pitch, the nose of the bird gets changed, like it is rotating towards the upper side. So what is getting changed? It is changing the z axis of the bird. Okay, the rotation of the bird is getting changed on z axis. And similarly for the scale, similarly for the scale, for the scale we need to write local scale, and simply we just give the exact value as new vector 3. Okay, new vector 3, speed 0 0. So in our case it will have an absolute value, it won't get increased. Okay, rather than just movement, it won't get increased, it will have an absolute value. Okay, so I played it, and I cannot see my cube because it simply got vanished. Why? Because the value of that game object is 0. Okay, what if I increase it? The scale is getting increased, but y and z are still 0. So the cube is getting scaled on 1D. Okay, one dimensions. Okay, other two dimensions are not visible for me. Okay, so why? Because for the other elements I have kept 0. So what I can do is I'll simply write speed and speed. Okay, so it will scale equally. It will scale equally on every dimensions, x, y, and z. Okay, 3 dimensions. Okay, I hit play button and again the cube is vanished because the scale is 0. If I increase the scale, the cube is getting increased by its height, length, and breadth. Okay, but supposedly I want to have it continuously moving with the scale. Okay, so it need to have a certain mathematical changes for this. Just we can simply write, you know, transform dot local scale is equal to transform dot local scale plus 1. Okay, so for that I'll just simply write plus over here. That's it. I'll simply add plus over here, so it is denoting as it will keep increasing with a particular speed. It will scale in a particular speed. You can see it is growing in a particular speed. Okay, let's try again. Currently it is 0, so it won't affect anything because we are adding the local scale. We're adding whatever value it is getting added to local scale. So currently it is adding 0, so it won't change anything. So if I add 0.1, start increasing, it will start growing. Okay, start scaling, and it is way fast. Okay, so what I'll do is I'll simply add time dot delta time. Same here, time dot delta time. Again, time dot delta time. Okay, no difference. Now I'll increase the cube in 0.1, so in 1.1 decimal value. So on each second it will increase 0.1 value. Okay, on every 1 second. And if I hit 1, so on every second it will increase the scale by 1 units. Okay, is getting scale uniformly. Okay, but if I want to have scaled in one direction only, okay, so other things I can keep it as 0. So it will uniformly scale on x-axis as per my code. You can see it is getting expanded gradually on x-axis. Okay, or simply if you want to have a very defined value, like I want to have a very defined value one time, I just want to scale the cube. Okay, I just want to scale the cube in just one fixed value, so you can simply write it in the start method. Just you want to have it in a very fixed value, just I'll write it the defined value. Like let's say the current cube value is 1, I want to set it to 2. Okay, so this will be a defined value and it won't change. because we don't need to write it on the update method. It will simply change the scale of the cube. Okay, it will simply change the scale of the cube. Okay, currently it is 4, like let's say it is 1 right now, or maybe it is 1 to 1. Okay, so what will happen, it will override to 2 to 2. Okay, it got overridden on the start method. Okay, this is how you do it. Similarly for rotation as well, transform dot rotation, okay, is equal to quaternion dot Euler. If I want to rotate it on the y-axis, on the fixed, I want to make it fixed, rotate it towards a particular angle. What I'll do is, if I want to rotate it on the y-axis on 90 degrees or maybe 45 degrees, what I'll do is I'll simply write 45 degrees on y-axis. Okay, so it will transform, scale and rotated. You can see transformed and rotated simultaneously. Okay, it changed the shape and rotated. Okay, and similarly if I want to move in specific direction, I can simply write this, not by the speed, I just want to change the position. I want to change the position, so simply I'll write transform dot position. I want to have a certain position, let's say I want to have on 2, 0 and 0, so it will be placed on x-axis 2 units, y-axis 0 units and z-axis 0 units. So it will position itself to this particular coordinates. So what will happen, it will scale, it will rotate and it will reposition to a particular coordinate. So coordinate means xyz position on the world position, or maybe you can say a global position because it has been placed into the root of the sea. Okay, so if I hit play, so it got moved, it got rotated and it got scaled. Okay, so for one time axis, one time things, you can simply do it in the start. Okay, so it will be called only once for initialization purposes. Okay, and again I forgot to mention, this is how parameter works, parameterized method works. Okay, if you see, I passed 5 and 10, it got added 5 plus 10, 15, which got stored in C and we printed C. So it will, so we have written 15. Okay, we printed 15. So previously I also mentioned that each and every right side, RHS side of the value goes to LHS. Okay, so basically visually on the mathematical side it seems LHS is equal to RHS. On the programmatically side it is LHS equal to RHS, means RHS, right hand side of the code or value, it is going towards the left side, or maybe you can say it is getting stored into the left side of the value, or you can say left hand side. So left hand side gets saved whichever things is present on the right hand side. Okay, so a plus b, so a plus b, which is 5 plus 10 is equal to 15, it got converted into 15 and got stored into the C. Similarly here we also do in this similar manner as I mentioned before. So we are everything here is going inside here. Here it is going inside here, and here it is going inside here. So we are basically putting those values to left hand side. Okay, so this is the, you know, you have to just remember it, like whichever things is on the right will, after the is equal to, will go to the left, it will get saved to the left. Okay, you have to make sure of that, you must remember it. Okay, so any doubts till now?
No, sir.
Okay, all right. So yeah, you can pass your attendances into the chat, and after doing that you may leave for that, as I'll simply hit your attendance respectively. Okay.